Alright, let's take a look at the electrolysis of aqueous solutions featuring copper sulfate. Now, the electrolysis of copper sulfate is something that you need to know for most exam boards for your GCSEs. Okay, aqueous solution. What does this term mean, aqueous? Aqueous simply means dissolved in water. Dissolved in water is sort of like a solution. If salt dissolves in water, it's an aqueous solution. In case you forgot how electrolysis works, I'm gonna get a little, let me move down a bit more. And let me draw that a bit better. Hopefully you get the idea. That's our beaker. And we're gonna have our anode and cathode, like so. And that's connected, and it's all powered by a battery that powers the movement of electrons, right? On this side, we're going to have our anode. Now, anodes are positively charged because opposite charges attract, right? An easy way to remember is anodes attract anions, negatively charged electrons. That's why it's positively charged, because opposite charges attract, right? If that's the anode, what's the other side going to be? It's going to be the cathode. The cathode is negatively charged. And it attracts cathodes, which are positively charged. Right? Pretty simple, pretty self-explanatory. And then we have a battery powering the movement of electrons across, right? So, step one, we're going to first have copper sulfate, right? Let's work out our which ions we have. Copper sulfate is CuSO4, by the way. So we have a copper atom, sulfur atom, and 4 oxygen atoms. So work out which ions. What ions do we have in the solution? If you forgot what an ion is, ions are basically just charged atoms. So usually atoms will be neutral, but if they lose or gain electrons, they'll either become positively charged, which means it's a cation, and negatively charged, making it an anion. And this is what gets attracted to either side of our electrolysis setup, essentially. So what ions do we have? Copper sulfate, right? CuSO4. Copper is Cu2+. It's got a Cu2+ charge. What does a 2+ charge mean? It means it's lost 2 electrons, so it has two more protons than electrons. Remember, usually you would have the same number of protons and electrons, but if you lose electrons, you're going to have more protons, right? Protons are positively charged, so it's going to be a Cu2+ because you lost 2 electrons. We have sulfur. And this is actually a molecule together. If I can draw. Actually, let me just switch our color. CuSO4. And then SO4 is one molecule together. And it's got a 2- charge. So this has the electrons. This has it has lost 2 electrons. This has gained 2 electrons. So we could say this is an anion. And this is a cation. Positively charged, negatively charged. Okay, and then we noticed that copper sulfate, it was dissolved in water to become an aqueous solution, right? So I forgot to mention here, we're going to have our electrolyte. Electrolyte is basically just the solution that you're using electrolysis for in order to get rid of. If you don't know what electrolysis is, watch my previous video on it that explains the basic concept essentially. I'll link it down below. Electrolyte, and this electrolyte is an aqueous solution, right? Aqueous copper sulfate. Aqueous dissolved in water, right? So we're going to have water as well. Water is H2O, right? We have OH- and we have H+. So this one has lost 1 electron to become a positive hydrogen atom. Lost 1 electron to become a to become a negative hydroxide. Okay, and then now we know we have another anion here. and we have a cation here, positive and negatively charged. Now we have next step. Step 2. What will be discharged? Which ions are going to be discharged? By discharge, I mean like lose your charge to become neutral. So let's begin on our cathode side first. Remember, the cathode side is over here, which attracts cathodes. It attracts positively charged stuff. Let's begin with our cathodes. If we look previously to our previous slide, we had a cathode of copper, and we had another cathode of hydrogen. So we had Cu2 plus, and we had H plus as well. What's going to get discharged? By discharged, I mean we have our cathode side on our electrolysis, right? So what's going to get attracted here, the copper or the hydrogen? It's definitely not going to be both. So what will get attracted? Well, to find out, we need to use something called the reactivity series, which you probably learned before starting this unit. Reactivity series. Now, this reactivity series may or may not be provided depending on your exam or when you take it, but I have this really easy song that I use to memorize the reactivity series. It goes like, first a bit embarrassed to sing it, but first up potassium, sodium, and calcium, but I just remember that I have lithium in there as well. First up potassium, sodium, and calcium, magnesium, and aluminium, just for comparison. Carbon set to join with them. It's not really a metal. Zinc, iron, tin, and lead. Don't know the symbols for those. Zinc, iron, tin, and lead. Hydrogen and copper next. Silver, gold, and platinum. We don't really need to know all this for your GCSE, but it's useful to know. Anyways, look at our reactivity series. First, the potassium, sodium, and calcium, magnesium, and aluminium. Just for comparison, carbon set to join with them. It's not really a metal. Zinc, iron, tin, and lead. Hydrogen and copper next. Silver, gold, and platinum. I'll leave this thing down below. It's really useful. Anyways, we have our copper, and we have our hydrogen. What's higher in the reactivity series? So we have our hydrogen over here, and we have our copper here. So hydrogen is above copper in the reactivity series, right? So it means hydrogen is more reactive. The thing that gets discharged, the less reactive one, gets discharged. So that's the one that's going to get attracted to our electrolysis equipment, right? To our cathode. That's what's going to get attracted. So what's less reactive? Our copper is less reactive. So our Cu2 plus gets discharged. It loses its charge. And I'll explain how this works in just a moment. So our copper gets discharged. Now, let's take a look at the anode side, the negatively charged side. What anodes did we have before? We had our OH minus, and we had our SO4 2 minus. So we have our SO4 2 minus, and we had our OH minus, right? What will get discharged? This time it's not really the reactivity series, it's a bit more of a different method. How do you know which gets discharged? So, there's a rule. If a halide, the rule number 1, let me just change my color. This red just looks quite dull. If a halide, now if you know the periodic table, you know halide is group 7. If a halide is present, it will always be discharged. It will always be discharged. So think of this as priority 1. If you have a halide, it will always be the one getting discharged first. And then we have number 2, second priority. If there is no halide, I'll just write if no halide. So halide is group 7 again. Always the hydroxide. Hydroxide will get discharged. Okay, so number 1, do we have any elements from halide? Anything from group 7 of the periodic table? No. And by the way, the periodic table is 100% provided to you in your chemistry exams. There is no halide. So you move on to row 2. If no halide, always the hydroxide will get discharged. Our OH minus, our hydroxide, will get discharged next. So this OH minus gets discharged. So now we know our OH minus gets discharged because there's no halides out of 2, and the hydroxide gets discharged next. And we know our copper gets discharged because it's less reactive of all the elements involved. Then, how does the discharge work? This is step 3. How does the discharge work? Now, once you found out which ions are going to get discharged, now you're done with all the hard part, basically. Let's draw out our experiments again. So we're going to have our electrodes, a bit too high. We draw the electrodes one more time. We have our cathode, we have our anode, and they are connected and powered by a battery. Alright, and we'll have our electrolyte. And in our electrolyte, we're going to have our, what's getting discharged? We have our copper 2 plus getting discharged, and our OH minus, right? OH minus getting discharged. And remember, this is our cathode attracting our positives, and this is our anode attracting our negatives. So our anode OH minus, let me draw it in a different color. OH minus will get attracted to our anode side. This side has too many electrons, right? That's why it's negatively charged. More negative electrons than positive protons, so it's negatively charged. They get attracted to the anode side. On the cathode side, we have our copper. This side actually has too few electrons. It needs more electrons to balance out its positive protons. What's going to happen? The hydroxide will deposit its extra electron and form oxygen and water. Remember, it's OH, just a single minus, right? So it just has one extra electron. OH minus, the hydroxide, deposits its extra electron and it goes to form oxygen and water. Okay, so this OH minus deposits its electron, and it goes to form oxygen and water. We'll look at the formula in just a moment. So now the electrons are deposited, and the electrons are negatively charged, and this battery is powering the movement of electrons to the other side, where our Cu2 plus can receive electrons. Copper gains 2 electrons from the cathode. So this side, the hydroxide deposits it at the anode, and copper gains 2 electrons from the cathode, and the battery is powering the movement of electrons, forming pure copper. Remember, the whole point of this electrolysis, point of doing this, is to get pure copper and get rid of all the inconsistencies, like things you don't need. What's our formula going to look like? Well, the copper, you have our copper 2 plus, and we have our OH minus, right? So this is gaining 2 electrons, gains 2 electrons, and our hydroxide loses, not 2, 1 electron. Loses 1 electron. That looks bad. Let me just write it out. Gains 2 electrons, loses 1 electron. What's the formula going to look like? We have our Cu2 plus. It's receiving 2 electrons. and that goes to form pure copper. Now this reaction is a reduction reaction. Remember, there's a very easy acronym, oil rig. Oxidation is loss of electrons. Reduction is gain of electrons. It's a reduction reaction because it is gaining electrons. That's why this acronym is really useful, because the wording is like completely opposite of what you would expect. Then for our OH minus, we're going to need 4 of these actually. It's going to go to form 2 H2Os plus oxygen plus 4 electrons. It's depositing 4 electrons. So 4 of these deposit 4 electrons, obviously, right? This one, well, oxidation is loss of electrons. It has lost 4 electrons. So it's a oxidation reaction. Oxidation reaction. That is basically everything you need to know. Just to review the formulas again, we have our copper, our cathode, right? It's receiving 2 electrons, so it's going to lose its 2+ charge, right? It's become a neutral copper atom. It's a reduction reaction. Our 4 hydroxide, it's going to form water and oxygen, right? So we can balance our equation out using 4, 2, and 1, and it also deposits 4 electrons, and it is an oxidation reaction. Hope this explains the electrolysis of copper sulfate, and thank you for watching.